Hello everyone, welcome to another session of construction planning. Students, in lecture series of construction planning, we have started discussing about the network methods, and we have started with critical path method. So when we talk about, we have discussed the theoretical concept of critical path method, that it was invented by DuPont and Sperry Corporation of Germany. It is used in repetitive kind of projects. It is not useful for the research and development based projects. CPM is activity oriented process. Then we have discussed about the CPM applications, that the applications of CPM is in planning, scheduling and controlling. Then we have discussed about event timings and activity timings. After that, so in activity timings, after that we have learned about EST, EFT, LST, LFT. So that was all happening, or that was all done in the previous session. So today in this session we are going to learn two topics: numerical of CPM method, and then we are going to learn concept of floats. Today we are going to cover up two topics. This is very important: numerical of CPM method and the concept of floats. So starting with the numerical of CPM method, let us read the question. So here is our question number 1, that says that a figure representing the network having duration of each of the activity to be performed. Determine the total project duration for the network. So as you can see over here, there is an entire network is given to you in the question. This is activity from A to I, and you can see that above the arrow there is the name of the activity, and below the arrow there is the duration of the activity. So you can say activity A is having duration 4, B is having duration 3, C is having duration 1, D is having duration 2, E is having duration 4, F is having duration 5, G is having duration 6, and H is having duration 2, and I is having duration 2. So that is your network with the given logic, and the entire network is given to you. You have to find out the total duration of the project. Now students, when you want to find the total duration of the project, here I am repeating it again, that individual activity timings are given to you, and you have to find the total duration of the project. So we need to focus on event timings and activity timings. Let us see. So the network starts with day 0, as in the cricket, when the over number 1 is being bowled, but it still starts from over point 0, 0.1, 0.2. So the same logic goes with the project, that it starts from point 0. So let us start with it. So here is the broader version or the larger version of the network, in which you can see that on above the event number 1 I have written 0. That was my starting point. Now we want to travel from event number 1 to 6. So we'll go sequence by sequence. So first event number 1 to 2. 1 to 2. 1 to 2, there is only one path. Activity A, which has duration 4. So 0 plus 4 will be 4. Let us represent that. So as you can see over here, 0 plus 4, 4. Now coming to the point event that is we have gone 1 to 2. Now let us go 2 to 3. Pardon me, 1 to 3. So 1 to 3, there is only one way, that is activity B having duration 3. So 0 plus 3, 3. Let us draw that. So here is the timing for event number 3, that is 3. Now event number 4. Focus on the figure, students. On event number 4, you can see that there are two ways to reach event number 4. Either I can go from 1 to 4, either I can go from 3 to 4. So if I go from 1 to 4, 0 plus 1, 1. But if I go 3 to 4, then 3 plus 2 will be 5. So there are two options, that either I could write 1, either I could write 5. But as we have discussed in the previous session of TE, we have to consider maximum. So 1 and 5, the maximum is 5. So I'll write 5. Let us represent that. Alright, so as you can see over here, I have represented 5. When you are going from left to right, that is known as forward path analysis, you have to consider the maximum value if there are multiple answers. If there are more than one answer, we need to consider the maximum value. So that is event number 4, that is answer 5. Now coming to the event number 5. See the figure. Again, there are two options, 3 to 5 and 4 to 5. So if I go from 3 to 5, answer will be 3 plus 6, 9. And if I go from 4 to 5, 5 plus 2, 7. So 7 and 9. There are two options, 7 and 9. So we'll write 9. Let us write it. So as you can see, event number 5 is having 9. Now talking about event number 6, that has three ways, 2 to 6, 3 to 6 and 5 to 6. So if I go from 2 to 6, it will be 4 plus 4, 8. If I go 3 to 6, 5 plus 3, 8. And if I go 5 to 6, then 9 plus 2, 11. So 8, 8, 11. So that is maximum answer is 11. So the final point will be 11. So that is how we can complete our forward path analysis. Students, what we have done here is we have completed forward path analysis. Now this is known as forward path analysis. Now to highlight, because there are activity name and there are activity duration, and I am writing above the event, I am writing this TE or the event timings. So let us represent in a square box. So as you can see over here, I have represented the event timing, the forward timings in a square, to just have the understanding that to have the separation of the multiple digits. So I have represented in a square box, just as a denoting. There is no logic behind it, that why we put on a square, because now we are going to learn the backward path analysis. We are going to learn backward path analysis. Now the backward path analysis says that what is the last point, that is event number 6, that was being completed on 11. So write again below that. So I am writing 11 again below the event number 6. So as you can see over here, I have write 11 below the event number 6 in a triangle. So the forward timings will be represented in a square and the backward timing will be represented in triangle. Alright. So both the up point and down point of event number 6 has been completed. So now I have to reverse. Initially in forward we went from 1 to 6. Now we are going 6 to 1. So sequentially 6 to 5. Now when you are talking about backward path, then students, now we are going from 6 to 5. So the logic is how many arrows are coming out of event number 5. How many arrows are coming out from event number 5? One arrow, 5 to 6. So there will be reverse only one path, 6 to 5. So 11 minus 2, that will be 9. 11 minus 2, that will be 9. I hope we are clear about the first step in our backward path analysis. Now let us talk about the event number 4. So when we talk about event number 4, so we are going from 5 to 4. So let us check that how many arrows are coming out from 4. So there are one arrow who is coming out from 4 to 5. So reverse path will be possible only one. So again 9 minus 2 will be 7. 9 minus 2 will be 7. Let us represent that. So as you can see over here, 9 minus 2 equals to 7. Now talking about event number 3. Now talking about event number 3. That has the 3 outgoing arrows. So there are 3 reverse paths possible. 6 to 3, 5 to 3 and 4 to 3. So if I come back from 6 to 3, 11 minus
5, that will be 6.
If I come back from 5 to 3, 9 minus 6, that will be 3. And if I come back from 4 to 3, 7 minus 2. 7 minus 2. So that is 5. So 5, 8 and 3. 3 answers are possible. So we need to consider the minimum value out of them, because we are doing the backward path. Right? So 8, 5 and 3. So minimum is 3. So the event number 3 have the TL as 3. Let us represent that. So as you can see, event number 3 is having the TL as 3. Now talking about event number 2. So event number 2 as having only one arrow, 2 to 6. So reverse will be 6 to 2. So 11 minus 4, that will be 7. Let us represent that. So here is for event number 2, that is 7. Now talking about event number 1. Now talking about event number 1. Event number 1 has 3 outgoing arrows. So reverse path will be 3 possibilities. 2 to 1, 3 to 1, 4 to 1. So if I go from 2 to 1, 7 minus 4, that will be 3. If I go from 3 to 1, 3 minus 3 is 0. And if I go from 4 to 1, that is 7 minus 1, that is 6. So 6, 3, 0. Minimum is 0. Let us draw that. So as you can see, for event number 1, again TL becomes 0, or latest event time becomes 0. So we have started from the point 0 and we came back for up to point 0. So that is how the sum works. This is forward path and backward path. I hope we are clear up to this point. So our purpose was to find out the total project duration. Our aim was to find out total project duration. So that will be 11 days or whatever unit given to you. Because at the end event, the event number 6 was the last event, we completed at 11. So that is your final answer. Let us write it down. So here it is. Total duration of the project is 11 days. Now, students, that was only one question. What is the total duration of the project? But now, let me tell you, what if there were 2 other questions, such as what is the critical path of the activity? Second, prepare the table of floats. there are two cases. First, prepare what is the critical path of the network. Second, prepare the table of floats. Now, what is a critical path? We know that what is critical activity? Critical activities are those activities which are required to be performed in very crucial manner, or they have to be completed within time. If they are not completed within time, the entire project duration will get disturbed. So critical path is a path or set of activities which are required to be performed in timely manner. If not, then entire project will get disturbed. So that is your critical path. And to find the critical path, we need to learn the concept of floats. So let us move ahead with our next topic, that is floats. So floats denotes a flexibility range by which the start or finish time of an activity can be fluctuated without affecting the project duration. I am repeating it again. Float denotes a flexibility range by which the start or finish point or time of the activity can be fluctuated without affecting the total project duration or without affecting the project. So basically, in simpler terms, students, float is a free time available with the activity by which if I start the activity early up to that time or I finish the activity late by that time, the project duration will not get disturbed. That value is known as float. But here in our case, we need to understand four kind of floats. There are four kind of float. First is total float, second is free float, third is independent float, and the fourth is interfering float. Let us understand that. Starting with total float. So the total float is the time span by which the starting or the ending of the activity can be fluctuated without affecting the completion of the project. That is more or less similar to the concept of or the definition of float, that the total float is the duration by which the starting or the finishing of the activity can be fluctuated without affecting the completion of the project. So total float is the actual free time available with the activity. To find the total float, there is this formula LST minus EST or LFT minus EFT. Alright, so that is your total float. So now, what if any activity is having total float equals to 0? Now, what if any activity is having total float 0? Now, what was actual total float? Total float was the free time available with the activity. Now, what if total float is 0? That means activity has no free time. An activity has no free time. What does that mean? That means we need to perform that activity very accurately without fluctuating it. And that is your concept of critical activity. So if I want to find out the critical activity of the network or critical path of the network, what I have to do is I have to find the total float of each activity, and those activity who are having total float equals to 0, those will be my critical activity, and the path connecting to them will be critical path. I'm repeating it again, the entire thing. What if the activity's total float is 0? Now the total float was free time available with the activity. But if total float is 0, that means there is no free time available with the activity. That means we need to finish the activity in very timely and accurate manner. So that is your concept of critical. So those activities who are having total float equals to 0, they are the critical activity. So in the network diagram, if I want to find the critical activities, I need to check that whose total float is 0. Alright? So that is your total float. Moving ahead with free float. Free float is the duration by which the start or finish of an activity can be delayed or fluctuated without delaying the succeeding activity or without delaying the total float of the successor activity. Free float is the duration by which an activity can be delayed without affecting the succeeding activity, or an activity can be delayed without affecting the total float of the activity. That value or the time is known as free float. So free float and total float are almost similar, but there is a major difference. That is, total float is concerning about the total duration of the project, while free float is concerning about the successor activity only. I hope you are getting this. That the free float is the time by which activity fluctuated does not affect the total duration. Here, free float's value is indicating that fluctuation does not affect the successor activity or the succeeding activity. Now, to find out the free float of the network or the activity, that is the formula EST of successor activity minus EFT of that particular activity. Formula for the free float is EST of successor activity minus EFT of that particular activity. I'll be clarifying how to find the total float and free float while we are doing the numerical. So have patience. Next is independent float. Let us see. It is the access time available with the activity if the proceeding activity completes as late as possible and succeeding activity starts as early as possible. So it is denoted as IDF. So IDF equals to minimum available time minus activity time. So that is TEJ minus TLI minus TIJ. Alright, so that is the formula of IDF. Now the last is interfering float. Let us see that. The difference between total float and free float is known as the interfering float. So IF equals to total float minus free float. So these are the four floats. Now you might be thinking that where to use this float or how to use this float in real time project. So let me tell you students, we can use the float as, like, you know that X activity is your critical and Y activity is non-critical because it has a float of, for an example, 3 days. That means Y is having a float 3 days, so that Y can be started 3 days early or 3 days later. The project is not going to get affected. So what I can do as a project manager or as a civil engineer, I can use the resources of the non-critical activities for that free float for that total float duration to they can be engaged in the performance of the critical activity. So I can use the resources of Y activity for 3 days for X activities, because I know that Y activity can be started 3 days earlier or can be performed 3 days later. So we can use the we can manage and use the resources. That is the major use of the floats. Now the numerical which we were doing earlier, let us find the total float and free float in the network. So let us see the last portion of the network. Alright, so that was our final answer for the network when we were finding the total duration of the project. But now we are going to find the critical path of the network, and we are going to find total float and free float. So from this image we have to prepare, from this network we need to prepare a table. What is that table? Let us see. So a table will consist of this much number of column: activity, duration, EST, EFT, LST, LFT, total float, free float, and remarks. So there are 9 columns: activity, duration, EST, EFT, LST, LFT, total float, free float, and remarks. Now the activity and duration is given to you in the question or in the network. So let us write them down. Alright, so I have written down the activity and the timings. That activities are ABCD up to I, and the event timings and the activity durations are 4, 3, 1, 2, 4, 5, 6, 2, 2. So I have performed nothing over up to this point. I've just that what was given in the network I have translated into the table. Now I want to find the critical path. Critical path is directly connected with the total float, and the total float's formula involves LST minus EST or LFT minus EFT. So we need to find the 4 of them. So first we are talking about EST. So now let us come back to the question. When we are talking about EST, earliest start time, I am explaining for the activity A. When you are seeing the activity A, you can see 4 timings: 0, 0, 4, 7, 0, 0, 4, 7. So when you are talking about EST is the ahead portion of the activity and the upper value. Ahead portion and the upper value. Ahead portion and the upper values. That is 0 for A. I am repeating it again. EST is the ahead portion of the arrow and the upper value. So for A, if you look at closely, for A, ahead portion, that means from event the starting point, that is from event number 1, and the ahead value is 0. For activity B, that will be again 0. For activity C, that will be again 0. So let us write it down in the table. So as you can see in the table, I have written down 0, 0, 0, 0, 0, 0. Now let us talk about D. So as you can see, D is downward. So ahead upper value, ahead of the arrow upper value, that will be 3. So that is for D. For E, it will be 4. For F, it will be 3. For G, it will be 3. For H, it will be 5. For H, it will be 5. And for I, it will be 9. So this is how EST can be obtained from the network. Let us write it down. So that is my complete column of EST. Now the next is EFT. So when I want to find EFT, I need to add the duration in EST. So for A, duration was 4, EST was 0. So EFT will be 0 plus 4, 4. For B, EST was 0, duration was 3. So EFT will be 0 plus 3, 3. Similarly, let us complete the entire table. Alright, so this is the entire table of EFT. So we have completed EST and EFT. Now the remaining are LST and LFT. LST and LFT. First we learn LFT. To learn the LFT, again we need to see the network. Let us come back to the network. Alright, so that was our network. Now I'm talking about the activity A. Again you can see 4 values 0, 0, 0, 0, 4, 7. So later portion of the arrow and below value is your LFT. Later portion of the arrow or the end portion of the arrow and the below value. For so A, that will be 7. For B, that will be 3. For C, that will be again 7. So let us write it down in the column of LFT. So LFT that was for A, it was 7. For B, it was 3. For C, it was 7. Again, let us come back to the network. So as you can see, for activity D, it will be 7. For E, it will be 11. For F, it will be 11. For G, it will be 9. For H, it will be 9. And for I, it will be 11. So these are the value of LFT. Let us represent that into our table. Alright, so here are the values of LFT. Now the remaining is LST. So LST is LFT minus duration of the project or the duration of the activity. So duration for A was 4 and the LFT was 7. So 7 minus 4, that will be 3. Now for activity B, duration was 3. For activity B, LFT was 3. So 3 minus 3, 0. So this is how we need to complete the entire table. Alright, so here is the complete table consisting of the values of LST. So now we have got LST, LFT, EST, EFT. So we can find out the total float. Formula for total float was EST minus EFT, LST minus EST or LFT minus EFT. You can apply any of the formula. So I am considering LST minus EST. For activity A, LST is 3 and EST is 0. So 3 minus 0, 3. For B, LST is 0 and EST is 0. So 0 minus 0, again 0. So that is how we need to complete the entire table. LST minus EST. So let us finish that. So here is the column of total float by subtracting LST minus EST. Now students, you can verify by subtracting LFT minus EFT. LFT minus EFT. So you can check that for activity A, LFT is 7, EFT is 4. So 7 minus 4, 3. For LFT for B is 3. EFT for B is 3. So 3 minus 3, 0. So answer will be the same as you have done in the LST minus EST. So that is your verification. So you cannot have any settings while doing the forward and backward. If your target is to have 0, 0 on 1 and you can misplace the values in between, you will be caught here. So that is, you have to perform this very logically. So that is how we'll consider the total float. So here there are 3 activities whose total float is 0. Whose total float is 0. B, G and I. So I'll write it down. critical in remarks. So I'll write it down, critical in remarks. Now you need to highlight these activities in the network. How? Let us see. So this is how you need to represent or highlight the critical activities in the network. By darken the path, and you write down the critical path for the project is BGI, either 1356, event numbers or activity names. Either of it can be you have to write. Alright, so that was up to total float. So I hope we are very much clear up to this point. Now learnings of free float and independent float or interfering float will be done in the next session. So this is it. That was all about in today's session. In case of any query or doubt, you can always contact me on my mail or my number. Thank you.